Hello, my name is David Young, and this is my ENME 351 Lab 7. For exercise 1, we're tasked with finding the gain of a non-inverting amplifier circuit shown below. Using these equations, I solved for the gain, so we know that gain is equal to V out over V in. For an op amp, V plus is equal to V minus. And in this specific circuit, V plus is equal to V in, and V minus is equal to V out over the ratio of R1 over R2 plus R1. And solving for those two, we get gain is equal to R2 plus R1 all over R1, or 1 plus the ratio of R2 over R1. For exercise 2, we had to make a unity gain amplifier or voltage follower. This is my hardware, so basically the white wire right here is going into my potentiometer, which is then going into my V in. And this purple wire right here is going from V minus to V out, which that's the following portion of this section. This is my code, this is my Arduino code, and it's basically just taking the inputs and turning it into string values for the processing over here, which the processing is very similar to Lab 5. The only thing I added was portions to the legend here, and added values to the raw data file here. So in Lab 5 it was 2 data points, and now it's 4 data points, so I had to make some additions. This is the actual value, so as you can see, it's following the circuit with a gain of about 1, and except until you get to 2 volts where the op amp gets saturated. And this is basically because Arduinos are from 0 to 5 volts and not from -5 to 5 volts. So let's get that full scale range. For exercise 3, we were tasked with creating an inverting op amp with a gain of -10. Here we can see that the gain equation is equal to -R2 over R1. I chose my R2 value to be 10 kiloohms and my R1 value to be 1 kiloohm. And this is a diagram of the circuit I created. Here's the actual circuit. This is a voltage divider using 1 kiloohm resistors here. My potentiometer, and the big difference between this and the last circuit are the resistors in between V in and V minus, and the resistor between V minus and V out. This is my voltage diagram for the circuit, and as you can see, when it approaches with small changes in V in and V minus, we get large changes in V out, and we can see it plateaus around just above 4 volts and just under 2 volts. And this is basically because of saturation at its positive supply. And let's get a full scale range here. So that's all the way at the bottom, all the way at the top. For exercise 4, we're tasked with creating an integrating op amp. This is a diagram of the circuit and the math to get to the V out equation. So V out is equal to -1 over RC times the integral of V in dt. For this circuit, we chose our resistance to be 4.7 kiloohms and our capacitance to be 10 microfarad. This is the circuit. The only real difference between this and the last circuit is the change in capacitance and resistance. This is our diagram, our voltage chart for the circuit. So as you can see, with small changes in V in, we get large changes in V out, which is impressive which has an impressive gain compared to the last 2 circuits. Also, when let's see if I can get it to it. Alright, so I stopped touching it, and you see that we get a positive slope all the way up to the saturation point, which helps solidify the fact that the output voltage is the integral of the input voltage. And let's get a full scale range for this circuit. Yeah, as you can see, with small changes, you get pretty big dips. That's it. Thank you for listening to my ENME 351 Lab 7.